Hello, Java programmers. Let's talk about UML, Unified Modeling Language. This is not a design course, but you really need some context to have a much better understanding of how we do work. And mostly in this course, and probably most of your programming courses, you start with a one-page description of something or some pseudocode or a flowchart. And that's appropriate and correct, but even before that happens, let's look at some other ways that we design software. A tool that we can use is UML. It is a well understood, common language that designers speak. It has a standard. On my screen is uml.org. The standard is over 600 pages. I do not recommend that you read it. I had, at one point in my graduate studies, gave myself a goal of reading it. I went into work one day and that was my plan, to become totally versed in UML. And I sat down at my desk in my advisor's lab and opened up my laptop, browsed to uml.org, downloaded the standard, noticed it was 600 pages, and never looked at it again. UML is a set of tools that you can use to create design diagrams for a variety of things. We're going to create a class diagram today. UML does not tell you how to correctly use the tools. It simply defines the tools. It's like going to Home Depot and buying a hammer and trying to use it as a screwdriver. I mean, you bought a tool and Home Depot sold it to you, and it probably has a good use for some application. However, a hammer used as a screwdriver is probably not correct. So we're going to look at applying some UML notation to communicate the design of software. I am going to use a program provided a long time ago by a website called Topcoder. Topcoder started out as a contest website where programmers could sign up and compete with each other to solve problems, and then they get points, like Reddit, I guess. They eventually added cash prizes, and they expanded to all kinds of other contests like system design and bug fixes. It's a very elaborate site right now. To me, it's exciting because I can sign up for a contest and I can spend an hour and a half writing programs, and then at the end, if I get them correct, I get points, and that's, to me, is neat. If you want to take part in Topcoder, I would certainly encourage you to do so. You may have to do some browsing and searching. The site now is rather elaborate. It just doesn't drop you into the contests anymore. But they have weekly contests most of the weeks. You sign up for free. They put you in a room, a virtual room, with other programmers. It's randomly distributed, so you don't know who's in your room. And they give you 3 problems to solve. It's anonymous. You can use a handle. They won't tell anybody who you are, and no one will know if you never get the problem solved. The problems range from what would they call a 250-point problem to a 1,000-point problem. The 250 is exceedingly simple. It's probably a loop and an if for the most part. And the algorithms are easy. The 500 is challenging. The 1,000 is almost impossible. But just to get one of them solved is a great rush if you like to program. It's not part of this course. You don't ever have to go here, but It's one more thing that would build your skill set and something you could put on your resume. Most of you probably know there are numerous competitors to sites like this anymore, and everybody has their favorite coding contest site. But this is one of the originals, and it's still fun for me. But the reason I showed you that is because I downloaded a tool that they provide for free to do UML diagrams. You don't have to use this tool. I checked the other day and it is still there. Even though it's been around for quite a while, they're still providing it as far as I know. You can use a web-based UML tool. There are oodles and oodles of tools. If you just type in UML tool in your trusty search engine, you'll get many, many of them. Some are good, some are not, some are easy to understand, some are more obtuse. You may have to search around a little bit. I posted on Canvas somewhere. Let's look. I posted in module, oh, that's the wrong course, I think. Hold on. In module 4, learning materials, I linked to a UML tool that's online based, endorsed by students in previous classes. They seem to like that one. I also linked to the one that I'm showing you now. When you transmit a UML document to me, be sure that you do it in some portable format like PDF. Because if you send me some UML diagram created by some website that I've never seen, I probably won't be able to open it. Many of the tools that you use in the online UML products don't even have a download feature. Therefore, you wouldn't be able to send it to me anyway. But just keep in mind, if you do submit one to me, make sure it's a format that I can open. Just snip the screen, probably is the best thing to do. But I am going to jump into my tool and build a simple class diagram just to illustrate how it works, and we'll talk about it. I want to point out this thing is written in Java. It's not the greatest. It's a little quirky, but it does get the job done if you're willing to invest the time. There are different diagrams that are supported. I'm interested in a class diagram. And later on we may do an interface and other things in a UML diagram, but for now we're just going to do classes. So File, New, Java is my project language, and that becomes important in a few minutes, you'll see. And then I can create a new class, I hope. Oh, I need a document first, or do I? Sorry, it's been a year. Okay, it's not cooperating with me. Hold on. I found it. My bad. I need to do a create diagram and then class diagram. That creates a workspace for me. You can give it a title. One of the worst things you can do, as far as I'm concerned, is leave the default text in any label. If a label is added to a diagram and it's the default, it just looks unprofessional. So put something in there. And then once we have the class diagram, we can add a class to it. Over in the elements, there is create a new class, there is create a new interface. We haven't talked about interfaces yet, but we will. So we want a new class, and I think then we just, do we drag it over? I'm embarrassed. Press the button, click over here. There it goes. A little bit quirky, but you'll figure it out. And let's say that we're modeling something off the top of our head, and let's model a dolphin. Dolphins are wonderful sea creatures, incredibly smart, and They come in pretty colors. And then we know from our experience that a class has properties and methods. So we're working from, and you don't have this right now, but you would be working from some type of systems analysis document provided to you by your systems analyst or generated by yourself. And from that document, you would be mapping entities of the system into classes in Java. Again, we're skipping some steps. We're not going through the design process. We're not holding in our hand a very nice design document provided by a domain expert. We're just creating a class diagram for the purposes of illustrating how to create a class diagram. We can add to this properties. At the bottom of the screen, there's a little tab window, and I can add properties. They're referred to as attributes. We call them properties, but this tool calls them attributes. So you click on Add Attribute, and it has a name, and we're going to say that this dolphin has a name. It's a wonderful sea creature, and we're very endeared to it. We've given it a name. It can be a data type, as you might expect. Let's say that since it is a name, it will be a string. So we'll look for string in this list. There's string. We will not provide an initial value. There is only one of them, so multiplicity is 1. It's not static. We haven't talked about static class members yet. And it's private because according to our design rules, if you create a property, it's automatically private. We don't make properties public unless we have an extremely good reason, and to this point in this class we have not discussed any such reason. Look up at the top in the class diagram now, you see that that property appears. Then let's create another property. So we're going to somehow add another property, and I think it's this here. No, that's a stereotype, don't worry about that. And the way we're going to create another property is, and I think you're seeing now how much this tool is something that you might not want to use, but hopefully you will either spend the time to learn it or find one that works better for you. In the properties section of the class, a little icon pops up, and I can click that, and that adds another property. So a lot of things about this tool aren't intuitive, but I am able to add another property, and I can give it a name. So let's say that it has, let's say it has a number, and that's an integer. So this dolphin has a number along with the name, just for the sake of argument. So we changed it to integer. We made sure it's private. I don't know what frozen means in the context of Java. It must translate to some other Java keyword because there is no frozen keyword in Java that I'm aware of. And then let's give it more properties. But before we do that, think about what we always do when we add a property. We always add a getter and a setter, or at least we think about it. If I right click on that property, you can see it says create getter and setter. And there are two methods magically created for us: get name and set name. Using the terminology that we've already defined, the naming style is just like we've done in previous exercises. So there is some commonality between what we've done already and how this tool works. And if I look at one of those, I click on set name. It opens up the properties of the set name method at the bottom, and you can see that doesn't return anything. It has a parameter called name. You can click on that. So we're on our way to defining something that is a common language between developers. Also note that this is not necessarily Java specific yet. This could be any other object-oriented programming language. And that's exciting because we're still not pinning ourselves down to a language. We could at the last minute decide that we're going to do this in C++ and we still have a class diagram that mostly applies. And it's also something that people understand who are in the field. So if I give you this, you can look at this and say, yeah, there's a class called Dolphin. It has two properties, name and number, and there's a get name and a set name for the name property. And that's good news. Of course, we would also come back and do a getter and a setter for the number property. All right, this is getting useful and interesting, I hope. Let's add another class, and we're going to do inheritance on these two classes. So what could inherit from Dolphin? And since we're doing this for fun and there's no analog to the real world, let's add a class. Please add a class for me. There we go. No? Double click worked. Haha. And this guy right now is just his own little class just hanging out in space, but I can connect him to the Dolphin class through what's called a connector. You may have to drag it around a little bit. Like I said, it's not the most friendly tool in the world. How about if I just delete that and start over? Let's try that again. I have a feeling no one is going to want to use this tool after they see this demo. There, I've managed to create that generalization. The generalization is another term for inheritance. By drawing this arrow from the derived class up to the base class, we can say that our class 2, which doesn't have a name yet, inherits from Dolphin. And for the sake of having a good time, let's say that this class is called Dolphia I just made up a name, and that's a Pokemon. I just made up a Pokemon, Dolphiacom. I don't know what it is, but it inherits from Dolphin. So now the Dolphiacom has all the properties and methods that are present in its base class, which is Dolphin. And we'll add something to this guy, and we'll say that he also has some weird property. Let's add an attribute. What can this little guy do? He has a color attribute. We'll make that a string. Again, this is all just to illustrate concepts, so none of this really exists. Add a getter and a setter for this little color guy. Make sure you save it. Save the project. It saves it in an XML format. I honestly don't know what that is. Probably some kind of XML. And I will call this Dolphin classes. How about that? And we go on like this in implementing a systems analysis document, implementing some design document provided by someone in our company, and then this becomes the basis for our programming. But it gets really better, I promise. Okay, let's look and see what this tool can do now, and I hope you're sitting down. And I hope you don't have a drink in your hand because you might have to do a spit take. Watch this. Generate code. How about that? When you started this video, you weren't sure. Should I watch this or not? This seems really boring. But now look what we can do. We can generate code. I hope this was worth it. I can ask it to generate Java code. So I don't have to go through and type in the getters and the setters and the properties and the class files. I do have to go in and do some cleanup. I mean, there are standards we have to meet according to our programming requirements, but we get a huge head start in generating our code based on this design document. I hope that's very exciting to you. I'm going to hit model, and it needs an output directory, c:\temp. I know I have that. Click accept, cross your fingers. Let's go to temp. And let's look in the src folder. There we go. There's dolphia.com.java, and there's dolphin.java, and I don't know what's in there. Oh, there's the Java libraries. How about that? That's awesome. So it generated this code for us. It generated our base class, and it generated our derived class. Let's look at one of those in Notepad. We use Notepad++. It has some color in it. There is the template, the framework for your Java docs. Remember, our standard is to Java doc all classes and all methods and properties unless they are in the main. So we can start filling in Java docs. We can start adding code to this. It doesn't generate a lot of code, so the get names and the getters and the setters have to be written, but that's okay. We've saved ourselves a huge amount of time by allowing the tool to generate code for us. It did not generate an entire Eclipse project. This tool doesn't know anything about Eclipse. But it did put everything in that src folder, and we've seen that before. That src folder we've seen as part of the Eclipse projects that we create. We also didn't put anything in a package. You can see when I drill down into src, there's no package. But that is another thing this tool can do. I just didn't show it to you. Hopefully then you've got a running start at creating a class diagram. Let me emphasize that the annotations matter. In other words, to demonstrate inheritance, which this tool calls generalization, you use an open arrow, and the arrow points from the derived class to the base class. I'll repeat that. You use an open arrow, and the arrow points from the derived class to the base class. That is the way we communicate inheritance. If you were to do this and you use some other arrow, a solid filled in arrow or a dashed line, that would be wrong. This is the correct notation for demonstrating inheritance. So be careful that you document the relationships between classes the right way. And with that, I will turn you loose. Thank you for watching. Go find yourself a UML tool that you like. An online tool is fine. A downloadable tool is fine. You don't have to pay for it. There are plenty of free ones out there. If you'd like to download the Topcoder tool and do what I just did, it's well worth your time, but as you saw, it's a little bit quirky. And thank you for your attention.